Hey guys, here are notes for 11.3, triangle basics. So hopefully most of what we talk about here is review, okay? So a triangle is a plane closed figure formed by three segments joining three non-collinear points. So if I have three non-collinear points, means 3 points that are not on the same line, connected with segments, then we have a triangle, and this is triangle ABC. Okay, triangle is made up of three components, vertices or points. So for example, this triangle PQR has vertices point P, point Q, and point R. Sides, the sides are segments, so if you're asked to name a side, name them as segments. So segment PQ, using the segment symbol, segment QR, and segment RP. And those could be switched and they would be fine. Then it is made up of angles, and there's two ways to name angles. Sometimes if there's only one angle at a point, you can use that point. So for example, angle P. Another way to name angle P would be angle QPR. Then we have angle Q. You can name that angle PQR. And then finally, angle R, which can also be named angle QRP. Okay. Types of triangles. So one way to classify triangles is by length. Okay, length of the sides. The triangle that has no congruent sides is called a scalene triangle. None of the sides are the same length. So here's an example of a scalene triangle. None of the sides have the same length. A triangle that has two congruent sides is called an isosceles triangle. Isosceles triangle. If two of the sides are the same, it's isosceles. All three sides being the same, it's called an equilateral triangle. Equilateral triangle, and I think we actually talked about this a few days ago. Equilateral triangle. All three sides are the same length. Okay. All right, first example, I want you to pause the video and classify these three triangles by the length of their sides. Okay, so hit pause now, then hit play to see the answers. A is equilateral, B is scalene, and C is isosceles. Okay. One thing we need to remember is the sum of the measures of the interior angles of a triangle is 180 degrees. If you add up the angles on the inside of a triangle, they add up to 180 degrees. Okay, so now let's talk about how to classify triangles by the measure of their interior angles. First, we have an acute triangle. Acute triangle is a triangle in which all three angles measure less than 90 degrees. So this would be an example of an acute triangle. An obtuse triangle, a triangle in which one angle has a measure greater than 90 degrees. So be an obtuse triangle. And then a right triangle is a triangle with exactly one angle that measures 90 degrees. And then finally, equiangular is a triangle. All three angles have equal measures. So if I have a triangle that's equiangular, all three angles have the same measure, and it would be exactly 60 degrees. All right. Let's look at example 2. So what I want you to do is I want you to pause the video and do example 2 and classify those triangles by their angles. And when you think you got it, you can hit play, see if you've got the right answer. First one is equiangular. Second one is an acute triangle. Third one is an obtuse triangle. And the last one is a right triangle. All right, so number 3, example 3 says, find the measure of the third angle of a triangle if the first angle has a measure of 66 and the second angle measures 37. Well, they have to add to 180 degrees. We don't know what the third one is. If I was to subtract 66 and 37 from 180 degrees, it would give me 77 degrees is the measure of the third angle. Okay. All right, let's look at number 4. It says find the measure of each angle of triangle RST. Again, all 3 of them have to add up to 180 degrees. So I write an equation, x plus 3x plus x plus 40 equals 180 degrees. And we solve this equation. So first I'm going to combine like terms. Move the 40 over. I'm left with 5x equals 140. Divide by 5. X is equal to 28. Which is angle S, so that's 28 degrees. Don't forget the degree symbol. 3 times X is 28 times 3 is 84 degrees for R. And then 28 plus 40 will give us 68 degrees for the measure of angle T. Okay. All right. Moving on, let's go to the next page. Look at example 5. It says find the value of X. Well, they're all equal, therefore it's got to be equal angular. Therefore 180 divided by 3 will give me 60 degrees for angle X. So this triangle is an equiangular triangle. Equiangular triangle. We can also say, because it's equiangular, each angle is 60 degrees. So if it's equiangular, all angles will measure 60 degrees. Okay. Let's look at example 6. Example 6. We want to find X. Well, it's a right triangle, so you can do one of 2 things. You could do 90 plus 3x plus 2 plus 2x plus 30, or 3 would equal 180. Or, since that one's 90, I would prefer to say 3x plus 2 plus 2x plus 3 equals 90 degrees. So I'm going to combine my like terms. Subtract 5 from both sides. I get 5x equals 85. X is equal to 17. X is 17. Okay. Angle J and angle L in this example would be classified as what kind of angles? Well, they're acute angles. Okay. They're less than 90 degrees. Since their sum is 90 degrees, we can say that the acute angles of a right triangle are complementary. 2 angles that add up to 90 degrees are called complementary angles. Okay? All right. Next page. I know, it feels like a lot of notes, but hopefully this is review. Last page. Almost done. Hang in there. Says an exterior angle of a triangle is formed by one side of the triangle and the extension of an adjacent side. To find the measure of an exterior angle of a triangle, add the 2 remote interior angles. Okay. So for example, angle 1 is an exterior angle. Okay, and then angles D and F are remote interior angles to angle 1. Okay, those are remote interior angles to angle 1. So this says that to find the measure of an exterior angle, add the two remote interior angles. So the measure of angle 1 is going to be equal to angle D plus angle F. Well, we actually know angle D to be 80 degrees and angle F to be 40 degrees, so the measure of angle 1 is equal to 120 degrees. Okay, it's just one of the facts that we need to know, that the exterior angle is equal to the sum of the two remote interior angles. Okay. All right, let's look at example 8. It says in triangle XYZ, the measure of angle X is 63 degrees and the measure of angle XYZ is 53 degrees. Find the measure of angle ZYR. So angle X is 63 degrees. XYZ is 53 degrees. Find the measure of angle ZYR. So this is the measure of this is the angle right here. Okay, ZYR, that obtuse angle. So there's a couple of ways to think about it. So one, well, we know the three angles of a triangle add up to 180. So we could say 180 minus 63 minus 53 would give me 64 degrees. And that 64 degrees is angle Z. And we just learned that the two remote interior angles add up to the exterior angle. So that means that angle, or the measure of angle X plus the measure of angle Z equals measure of angle ZYR. So 63 degrees plus 64 degrees equals 127 degrees, and that is ZYR. Last example, example 9. Okay. Says in triangle EFG, the measure of angle G is 100 degrees. The measure of angle FEH is 3 times the measure of angle F. Find the measure of angle F. All right. So I'm going to name the angle F X, and then if FEH is 3 times that measure, it's going to be 3x. So this allows me to write an equation where there are two remote interior angles, so measure of angle F plus the measure of angle G equals the measure of angle FEH. F is x, G is 100, and we named that 3x. So now I have an equation where I can solve for x. So x is equal to 80 degrees. Okay, it wants the measure of angle F, not 80, 50 degrees. You gotta make sure you check my math. So the measure of angle F is 50 degrees. A little bit tricky, but no doubt you guys can handle that. Okay, so if you had questions on the notes, you can always rewind it and watch the part that you didn't get. Otherwise, get